Since day one, Team 4227 has been hard at work preparing for competition. We meet every Tuesday and Thursday, having fun as we overcome any obstacles along the way. We try to overcome these obstacles with ingenuity and gracious professionalism. Over the course of the year, our team has worked not only to develop a fully functional robot, but to inspire our community to innovate in the spirit of FIRST. This year's challenge provided several mechanical obstacles to overcome, something that our engineering team worked very hard on. Here is Zach Irving with more on some basic mechanical components of the robot.
So the most basic feature on our robot is our drivetrain, and we came up with the idea of using a 3-to-2 gear ratio in order to increase the torque of our robot so that we have enough power to get up the ramp, but also not have it be too much torque and not enough speed, so we balanced it out at 3-to-2. We also use stealth wheels to increase the friction due to their flat, greater surface area.
Not only do we build robots, but our team has worked extensively with Oviedo and the surrounding area at community outreach events and fundraisers. Our team held a summer camp to recruit new members, where incoming freshmen were taught the basics of robotics on both the hardware and software side. Metamorphosis worked at the Seminole County STEM Expo to expand interest in STEM fields among our community. At the Waterford Lakes Maker Fair, we continued our outreach through education of the population. With more on our outreach events, here is Karen Zhang.
We've helped mentor the FLL teams at local elementary schools such as Carillon and Parton Elementary and helped them design and build their robot, as well as high schools such as Krim's Academy and their team, the Frolicking Nerds.
Our team has put lots of effort into training new members and ensuring that all members of the team are able and ready to perform at all times. We require that all members take driving lessons with the robot, so game day is nobody's first experience with the robot. Before building our robot, we carefully planned the design out and then began testing. Here's Matthew Mason, who spearheaded our design effort.
After we came up with some simple mechanisms that we could use on our robot, we began using PTC's Creo software to basically build our robot in the computer.
Coupled with our strategy of meeting with other teams before matches to effectively pair our robots, this design process allowed us to find solutions and win.
The lifting mechanism on a robot is made up of multiple aluminum tubes which have holes drilled through them and rubber tubing threaded through them. They spin around and lift the blocks and the balls up into an acrylic basket which is placed on the top of our robot.
We fundraised through donations from local businesses, keeping track of funds in our budget. We then carefully planned what to purchase. We would also like to thank our sponsors.